Hello everyone, I'm Bhavyashri and today we'll explore key software testing methodologies including functional testing, system integration testing, user testing, and testing on different platforms. Let us dive. The topics covered in this video are functional testing, types of functional testing, system integration testing, types of system integration testing, user testing with examples, testing on different platforms with examples. Introduction to software testing. Software testing is a crucial step in software development. It helps in identifying bugs, ensures software reliability, and improve user experience. Broadly, testing is categorized into functional and non-functional testing. In this session, our focus will be on functional testing and its related aspects. Functional testing overview. Functional testing is all about verifying whether the software meets its specified requirements. It ensures that every function of an application behaves as expected. Given specific inputs, functional testing is done at multiple levels, including unit testing, integration testing, system testing, and user acceptance testing. Functional testing techniques. Now, let us talk about some key techniques used in functional testing. Functional testing is not just about running cells. It's about choosing the right approach for different scenarios. The first one is smoke testing. Think of this as a quick health check for your application. Before diving deep into the testing, we run some smoke tests to check if the critical functionalities are working or not. If they fail, we stop and fix them before proceeding further. The second one is sanity testing. This is useful when a small change is made in the application. Instead of testing everything, we focus only on the modified parts to make sure they work as expected. Next one is regression testing. Every time we add a new feature or fix a bug, we need to ensure that the existing functionalities aren't broken. Regression testing helps in rerunning previous test cases to confirm that nothing else got affected. And let us go to the next one, that is user acceptance testing, that is called UAT. And this is the final step before deployment. Real users test the application to see if it meets their needs. If users are happy, the software is good to go. So each of these techniques plays a crucial role in ensuring the software is reliable, bug-free, and meets requirements. So the next one is functional testing process. Now that we know the techniques, let us walk through the functional testing process step by step. First one is identify test scenarios. First, we carefully study the software requirements and identify the functionalities that need to be tested. The second one is design test cases. Next, we create a detailed test cases that define what to test, what inputs to provide, and what results we expect. Next one is execute the test cases. Once our test cases are ready, we run them manually or through automated tools to check how the application behaves. Report and fix defects. If we find any issues, they are logged, assigned to developers for fixing, and tested again to confirm they are resolved. So the next one is validate the final outcome. Finally, we review the test results and confirm that all the functionalities are working correctly before deployment. So this process ensures a structured approach to testing and helps in delivering a high quality product. Now let us talk about functional testing tools. To make functional testing efficient, we use various automation tools. Let us look at some popular ones. The first one is Selenium. Selenium, one of the most widely used open source tools for automating web applications. Test Complete, a great tool for UI testing with both script-based and scriptless options. QTP, Quick Test Professional, now known as UFT. It is widely used for automated functional testing. JUnit, a unit testing framework specifically designed for a Java application. These tools help in automating repetitive tasks, reducing manual effort, and increasing accuracy in execution of the tests. Now, let us move on to system integration testing, or it is also called as SIT. This is where we test how different parts of a system interact with each other. Even if individual modules work perfectly, they must function correctly when they are combined. For example, imagine a banking application. The login system, account management, and payment gateway may work separately. But what happens when they communicate? If integration isn't tested, a failure in one module could impact the entire system. So this is called system integration testing overview. There are several ways to perform system integration testing. They are top-down testing. We start testing with high-level modules first, then gradually integrate low-level components. In bottom-up testing, here we begin with the lower-level modules and then integrate with them with higher-level ones. In Big Bang testing, all components are integrated at once and are tested together. This is risky because debugging becomes difficult if multiple issues arise. The next one is incremental testing. The components are tested in small groups before full integration, making it easier to isolate problems. So choosing the right approach depends on the complexity of the project and how modules depend on each other. So the next one is system integration testing that follows a structured process to ensure smooth interactions between a system and a component. Understanding system requirements is the first step. We analyze how different modules are supposed to communicate. The second step is define test scenarios. We create test cases to verify data flow and interaction between integrated components. The third one is develop and execute tests, which is using real world scenarios. We test the integration points to check for failures. The fourth one is report and fix issues. Any defects found are logged and fixed before the final validation. So this step-by-step approach ensures seamless communication between integration modules. The tools for SIT. To make SIT more efficient, we use specialized tools. Some of them are Postman. This is used widely for API testing to check how services communicate. JMeter. It is great for performance and load testing to analyze system behavior under stress. SOAP UI, perfect for testing web services and SOAP, SOAP-based APIs. HP ALM, a test management tool for tracking integration testing process. So these tools help us stimulate the real-world interactions and ensure smooth system functionality. So now let us talk about the user testing. So user testing is very critical and it is very important. And here the real users interact with the software to test its usability and functionality. Their feedback helps identify design and experience issues that might not be obvious to developers. For example, if an e-commerce app is too complicated to navigate, users may abandon it, even if the backend works perfectly. That's why user testing is essential. Now, let us talk about the user testing process, which includes identifying target users, selecting users who represent the actual audience of the application. Second, creating realistic scenarios. Users perform tasks as they would in a real world setting. Collecting feedback, gathering insights through surveys, interviews, and behavior analysis. The fourth one is analyzing results and making improvements, refining the software based on the user feedback. This ensures the final product is initiative and user friendly. Now, the benefits of the user testing. They help in several ways, such as improves user experience (UX), identifies usability issues early, reduces customer complaints, enhances product success in the market. If users love the product, the chances of success increases. So, let us know why there is a test needed to perform on multiple platforms. With so many devices, browsers, and operating systems available in the software, they must work consistently across all of them. Platform testing ensures that your applications run smoothly no matter where it is accessed. The types of platform testing. The first one is cross-browser testing, which verifies if an app works on Chrome, Firefox, Safari, etc. Cross-device testing. This checks if it works on the mobile, tablet, and the desktop compatibility. OS compatibility testing. It ensures smooth operation on Windows, Mac OS, Linux, Android, and iOS, etc. The types of Tools used for platform testing. Browser stack, which stimulates the real world browser and device environments. The Lambda test, it automates cross browser testing. Appium, which is used for mobile application testing. Source Labs, which is used for cloud based testing across multiple devices and platforms. To summarize, functional testing ensures that the software meets requirements. System testing integration validates interactions. User testing improves usability, and platform testing ensures compatibility. Implementing these strategies leads to a high quality, user friendly product. Thank you for watching.